Okay, in this question they give us some data here and ask us to write a linear regression equation for the data. So, where x is the mass and y is the height. So this is a pure calculator question right here. So I've already put it in here, but let me just show you how to do it. We're going to put in all this data into stat, edit. Now this L1, we're going to plug in all these values, right? 4.5, enter, 5, enter, put that all in here, and then in the next column you're going to put in this row, 41, 40, 35, etc. And after you put that all in, be very careful though that you put it in accurately, because missing one small number or anything like that is going to throw everything off. After you do that, you go to stat, calc, for, enter, 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 and here. So it's given to us in the form y equals ax plus b. A is the x coefficient and b is the constant. So it's going to be y equals 1.9, they told us to round it to the nearest tenth, 1.9x plus 29.8. So y equals 1.9x plus 29.8. Okay, now for the correlation coefficient, so you're not going to get that unless your mode is set to diagnostics on. So to do that, you go to mode, and then you can see here towards the bottom there's diagnostics. I already have mine on, but if you don't, which is the default, you should switch it on. And if you can't find it there, or a useful thing, if there's anything you can't find, you can use the catalog, and to skip to the letter you want, in this case I want diagnostics, so alpha D, and I'll skip to D, and then I just look for diagnostic on, enter, and you can turn it on that way. One way or another, you turn it on, and now it will give you the R. It will not give you the R, which is the correlation coefficient, unless you have diagnostics on. So this R, that's the correlation coefficient. So our correlation coefficient is 0.3. They told us to round it to the nearest tenth. And what does that indicate? Well, correlation coefficient is a number between -1 and +1. -1 shows a strong negative correlation. +1 shows a strong positive correlation. 0 shows no correlation. So 0.3, right, that would show a weak positive correlation. So weak. Right, if it was -0.3, that would show a weak negative correlation. If it was -0.9, that would show a strong negative correlation. I get the idea. Okay, moving on to the next problem. Okay, so she has a movie card for 100. Tickets cost $7.50 each, and evening night tickets cost $12.50 each. So, if X is the number of, I don't even know how to pronounce that word, matinee tickets she could purchase, and Y represents the number of evening tickets she could purchase. So we want an inequality that represents all the possible ways that she could spend her gift card money. So the amount that she spends has to be less than the amount on the gift card, less than 100. And how much is she going to spend? Well, it depends how many of each type of ticket she buys. So the amount she spends is going to be the number of matinee tickets times $7.50. That will be the total amount spent on matinee tickets. And the evening tickets, the total amount spent will be $12.50 times the number of evening tickets, which is Y. So total amount spent is going to be 7.5x. That will represent the total amount spent on the matinee. So if she bought, let's say, 10, then it's going to be 7.5 times 10. That means she spent 75 on that. Plus the amount spent on evening tickets, which is 1250 times y, which is the number of matinee tickets she bought. And that is going to have to be less than 100. Now they're asking us on the set of axes below, graph this inequality. So, how do we do that? Well, I suppose the first thing to do would be to get y alone. Actually, if we get y alone, then we can just graph it on our calculator. So that's going to take a drop of algebra, subtract 7.5x from each side. So we'll have 12.5y equals 100 minus 7.5x, and then divide each side by 12.5. And let's see what that comes out to. Oh, calculator. Actually, we don't even have to divide that. We could just put it straight in as a fraction. Y is going to equal fraction with the numerator is 100 minus 7.5x. 100 minus 7.5x over 12.5. And since it's an inequality, we don't really need this, but it's going to be less than. Ooh, I should not have put a equal sign here. Right, this is less than. So to make it less than, we want it to be facing down. That would be greater than. This is less than. Okay. Now it should graph. And that's what our graph is going to look like. Now the best way to draw graphs is, well, first of all, we should note that the only part we're interested in is this side of the graph. We're not interested in negative down here. We're actually also not interested in negative down here because x and y can't be negative because we're talking about a number of tickets. You can't have a negative number of tickets. So actually we could make this a little bit neater by making the x minimum 0 and the y minimum 0. So we can just focus on what we're interested in. Really, we don't need to do this. The main thing is the table, really. So the table tells us that when x is 0, y is 8. So I'm going to plot that point 1, 2, 3, 4, 5, 6, 7, 8. It's going to be right there. When x is 1, y will be 7.4. So that'll be around there. Just to drop a little there. Next is 2, y will be 6.8. So it's going to be right about there. And we could skip a little bit. At 10, it's going to be 2. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we just make a straight line there like that, well, maybe not so straight. We want to make sure to get the x intercept right. So let's scroll. The x-intercept is where y equals 0. So let's make sure we get that point. When is it going to be 0? Is it going to be 0? No, it's not really quite going to be 0. So let's just draw like that. Okay. So, and then we have to shade it down. Oh, and actually this line should be dotted because it's less than, not equal to. Oh wait, no, it could be equal to. Really, it could be exactly 100. Exactly 100 is fine. So actually, therefore, it's not dotted. It's this is a solid line. Let's see, what's the next part? Oh, and also this should be labeled. Well, actually, there's nothing to label it here. Well, maybe this should be labeled 1, 2, 3, etc. And this 1, 2, 3, etc. The next part of the question is the maximum number of matinee tickets Miranda could purchase with her gift card. Well, the maximum number of matinee tickets that she can buy with the gift card is going to be, how much were the matinee? The matinee were $750. $750. So she has $100. How many can she buy? Well, that's going to be 100 divided by 7.5, which comes out to 13.333. And since you can't buy partial tickets, the most you can buy is 13. So, oops. So the answer would be 13, because 100 divided by 7.5, which is the price of those tickets, equals 13.3. And you might want to add in, and you can't buy parts of tickets. You can only buy whole tickets. Okay, last question, I think. Maybe second last question. So at 6 a.m. it was 50 degrees. So let's mark that down. At 6 a.m., maybe we should make this a drop smaller. So we don't have to keep scrolling up and down. At 6 a.m. it was 50 degrees. So let's plot there. For the next 6 hours, it rose 2 degrees per hour. So that means at 7 o'clock, it was, well, this is going by twos, it looks like. 2, 4, 6, 8, 10. Yeah, so it's going by twos. So at 7 o'clock, it will be there, 8 o'clock there, until, for the next 6 hours. So that means until noon, until 12 o'clock. Okay, so far not too bad. Then it stayed steady until 6 p.m. Well, first let's just draw a line connecting that. It stayed steady until 6 p.m. So straight line until 6 p.m. Then for the next 2 hours, it dropped steadily 1 degree per hour. So 1 hour, 2 hours. And then the temperature dropped steadily until it was 56 degrees at midnight. So at midnight, it was 56. 56 would be at 1, 2, 3, right up here. And midnight over here. And to get this line, you would use a straight edge ruler. Just make it going straight there. Okay, graph Elroy's data. Okay, that we did. State the entire time interval for which the temperature was increasing. Okay, well, obviously, it was only increasing from 6 a.m. to 12 noon, right? All the other, right, over here it rose. All the other time periods, it either stayed steady or dropped varying degrees. So, 6 a.m. to noon. Okay, determine the average rate of change from 6 p.m. to midnight. So, let's see, at 6 p.m. At 6 p.m. it was, at 6 p.m. it was 62 degrees. At 6 p.m. it was 62 degrees. And at 12 midnight, it was how many degrees? 60, 58, 56. It was 56 degrees. So, rate of change, right, is the amount of change over the amount of time. So, it's going to be, the amount of change is 62 minus 56 over, now we got to match it up. We did 62 first, so we got to do the 6 p.m. first. 6 minus 12. Okay, and that's going to equal, if you're not sure, you can just type into your calculator, but this should equal 6 over negative 6, which equals negative 1. All right, you could have also done the other way around, 56 minus 62, but then you would have to do 12 minus 6, and you would get the same result, negative 6 up here, and a plain 6 down there. Negative divided by positive is negative, so we would get negative 1. So the average rate of change would be 1 degree per hour, and you should probably write that, or negative 1 degree per hour. Is that it, or one more? Okay, the biggie, the 6-pointer. Okay. A recreation center ordered a total of 15 tricycles and bicycles from Sporting Good. When the number of wheels for all the tricycles and bicycles totaled to 38. Okay, so the total number of wheels. Well, how many is that? Well, we're going to have the tricycle wheels, which is 3 per tricycle, and the bicycle wheels, which is going to be 2 per bicycle. So they told us to call T represents the number of tricycles, B represents the number of bicycles. So T times 3, right? 3 times the number of tricycles, that's going to tell us how many wheels there are from tricycles, plus 2 times the number of bicycles, that's going to tell us how many wheels from bicycles there are. When you add them together, right, they told us that it's 38. So this is going to have to add up to 38. They also told us that the center ordered a total of 15 tricycles and bicycles. That means T plus B equals 15. Okay, so now they're asking us to create a system of equations. Okay, so one way you could do this is plugging in points. Figure out, you do one line at a time, right? When t is 0, b is going to have to be 15. When this is 1, there's going to have to be 14, right? So that's easy. You just keep going down. Or you could set it up as isolate t, get t alone, and you would get t equals 15 minus b. Either way, this is not hard to graph. So when t is 0, b would be 15. Let's put a mark right there. And actually, we don't even have to figure out each one. Since it's linear, we can just find the endpoints, or really any 2 points, and then use a straight edge, like a ruler or page, to draw a straight line. So when b is 0, which is going to be along this line down here, t is going to be 15, which is going to be right down here. And you would make a straight line, unlike this one. Let's see. Okay, that's good enough. Okay, so let's start off now with this equation. If t equals 0, so let's say t equals 0, so that would be 3 times 0 plus 2p equals 38. So this would be 0 plus 2b equals 38. Divide each side by 2, and you get b equals 19. So that means when t, for this first equation, when t is 0, when t is 0, which would be all along here, b is going to be 19, which would be way up here. Okay, now let's figure out when b is 0. Well, if b is 0, well, that's actually not going to be possible, because then you're going to get 3t equals 38, and 38 isn't divisible by 3. So we need to have at least one bike. So 3t plus 2 times 1 equals 38. We subtract 2 from each side, and we'll get 3t equals 36. Divide each side by 3, and we get t equals 12. So when there are no bikes, there can be 12 tricycles. That's right down here. And you'll use a straight edge so that everything will come out perfect. Let's try this. If you use a straight edge and draw the line perfectly straight, the point of intersection will be the solution to the system of equations. Based on your graph of this scenario, could they have ordered 10 tricycles? Well, that's close. According to the way I drew it, they can. But I wouldn't rely on that because it's not so straight. So let's play it out. Let's see. Could they have ordered 10 tricycles? So let's try plugging that in. If they ordered 10 tricycles, so let's see, for the first equation, right, t would be 10 plus 2b equals 38. So it would be 30 plus 2b equals 38. Subtract 30 from each side. We get 2b equals 8. Divide each side by 2. Get b equals 4. Okay, so in the first equation, if t is 10 tricycles, we get b is 4. And that does not work though for the second equation. If we have 10 tricycles and 4 bicycles, that's not going to give us 15. So I would say that the answer is no. No, because then you'll need 4 bicycles in order to complete the 38 wheels, but that's not going to be enough to complete a total of 15 total bicycles and tricycles altogether. So that would be the reason why it cannot be 10, even though it looks like from my messy graph like it is, in fact cannot be 10. And that's the end of the Regent.